Hello, everyone. Today, I will not talk about stuff as advanced as AI. I will come to a very basic security function, yet crucial in the ICS world, that is mastering privileges escalation. That is when someone wants to reconfigure a PLC or reconfigure something on the production line. And I will go through that example in the automotive world, which I've been working for several years now. And I will do some parallel and some little jokes in my talk. So that I entitled it Drifting Not Allowed, because actually you can prevent people from drifting with their cars if you master ECU privileges escalation. So first, let's look at what is an ECU, an electronic control unit. It's something hackers are actively targeting since 10 years now. That's a piece of hardware and software like that. You have roughly 100 in a car. They are historically dedicated to one precise function. So for example, that is quite a motherboard in a car. You have one for injection, one for brake mastering, one for steering. And over the years, they've become more and more powerful, more and more complex, up to having 100 in a car. The car has its own internal network that is highly specific to a given original equipment manufacturer that specifies the way it implements it and pushes that specification to suppliers, much like in the ICS industry where you build a production line and you ask for a system configuration, and inside of it you don't really know what's being built. So you have several functions in the car, the powertrain, the chassis, the body and electronics, that are like production lines with end of line that are the ECUs you see here. You have one central piece that is the in-vehicle infotainment that allows reconfiguring almost everything, you know. You can move your car from sports mode to eco mode that will drive injection, drive braking, drive everything on the car. And you have your driver that is, of course, an operator. So at that stage of my talk, I would like you to be sure that a car is like a plant on wheels that moves, and it has more or less the same timeline. I took a small example of timeline on the Tesla Model S that was started development in 2007, was revealed to the public in 2009. We have now 3 phases of Tesla Model S on the road, phase 1 from 2012 to 2016, and phase 3 started rolled out 3 years ago. And, well, I'm guessing people buying Teslas today are expecting their end of life to be after 2030. So basically something that was started developing in 2007, an architecture that has been designed now almost 20 years ago, will go until, well, at least 10 years more, I think. So 2 small examples to show you that car manufacturers are doing it to face real threat. The first one is RAV4 from Toyota. Do you know it's the flagship of Toyota? They are getting stalled on the street because hackers found out that you can reconfigure a GBL speaker to inject code on the car. You need to unmount a headlight, plug in the network, and then you inject code, and basically you can unlock the car and drive with it. So cars are getting stolen by mafias, by different type of organization that are, of course, illegal. But it is also now known that cars are vulnerable, so competitions are being organized, like the Point to Own. I took screenshots from the 2023 edition, but it also went live in 2024, a few years back. And they found 24 0 days on Teslas. That was, of course, bug bounted at the time. So after that introduction, I'd like to introduce you the road we'll go through today. Today we have 4 stops. The first one is, why do we look at the use case here, and why do we bother on securing such pieces of hardware? Now, I think you got it. They are real threats. We'll look a bit more on real use cases on the field. Second step is how. How are we facing that, and what can we do more? Plot twist, we're not going to go passwords, okay? That's not something that matches the challenges of the industry. Then we'll look a bit in depth at what suitable role model we could find and develop for those cars. That would be my third stop. And finally, and key takeaways, and I would like to emphasize that starting now, is that we could standardize all that because this is common ground. Car manufacturers, train manufacturers, ICS manufacturers, everybody has the same challenge. We have people that need to come and do privilege escalation on the product, on the system, and we would benefit from more standardization to make cyber easier and less costly. So, a whole hidden phase to achieve vehicle cyber. What's happening right now in the car industry? Well, first of all, you know, cars are getting connected because you would like your car to start before you get into it because you want it to be heated before you leave your car if you're from Norway or Sweden. And the regulation knows that, so it has started to emit strong cybersecurity requirements on the cars that specifically says you don't want anyone unauthorized to reconfigure the car. You want to be able to update your car and patch a bug because cars are more and more software-based, you know. They are moving from the OT world, I would say, where everything is predefined and pre-test, to the IT world where bugs exist and you actually need to fix them in production. When you fix a bug, you don't want your hardware to get bricked because that happens, so you want an update to succeed because hardware that is bricked costs a lot. You need to get back to your car mechanics, replace parts and stuff like that. And cars, especially electric cars, are fastening in the development. You've seen that phase of Tesla was every 4 years. The Chinese competition is coming, and so you have a fastening development cycle of the car products today that actually make them move more and more in the IT world. So I've taken 4 real use cases of the car industry here. The first one is basically when you build a car in the factory, you don't really know what part will end up in which car and the precise weight of the car, for example, which is a factor to configure your brakes. So once you're in the factory, you need to calibrate or configure the car as per the exact car that will go out of the line. You have devs that, of course, need to switch your part into dev mode and switch them back to regular mode when you're doing tests before releasing your car on the road. And you have your after-sale network. And I will dive specifically on the after-sale use case because I think it's the most challenging one. That your after-sale have a car that is malfunctioning, arriving, and for example, we need to have a whole lot more logs to understand what is malfunctioning and what he could do to fix the car. So that is diagnostic. Final use case, sometimes your hardware is malfunctioning and you're not getting why, so you just go for a full factory reset, which is also something that is being asked more and more by regulators. So in the end, at that stage of my pitch, I'd like you to be sure and convinced that we need to authenticate users against my piece of hardware that is an ECU, and we won't do that by leveraging thousands of passwords on the field. We need something clever, we need something more scalable. That's where cryptography comes in place. We all know cryptography, that is the basis of cyber to do encryption, and it's also the most obvious choice to authenticate my human being against my car. Why? Because first, well, you need to be scalable. You put roughly 1 million, 5 million for the biggest car manufacturer cars on the road every year, so you need something that works on your whole fleet. Then the ECUs, much like in the ICS industry, have really few software and power capabilities. They cannot do complex computation, they cannot retain a large number of secrets, so you need to adapt to that. That's my beam of constraint here. Next constraint in my beam is you cannot have a local directory. You know, in ICS, sometimes you put a directory in the factory and you say, hey, all my operators are in that directory and that works. Well, that does not scale to a whole country or a whole fleet of cars. You cannot do that. And last but not least, you need something that works in a disconnected mode because your car could have issues on the connectivity system and your car could also be somewhere you don't have any network. So here we relate to cryptographic authentication. I'm guessing you all know that it's pretty easy. You have a trusted certification authority that is being put on the car. I will dive in that. You generate a challenge at the car level. The operator signs it with his private keys and his public key that is trusted, and the car checks it, and that works. I think that's fairly straightforward. But do you really want your PKI, the public key infrastructure, to be exposed to all your car dealerships to emit certificate for the operators? I guess not. It's buried deep down in your IT system behind firewalls. Do you really see PKI systems on the field having nice user-friendly features and workflows implemented on them? Neither. I mean, Microsoft PKI from AD, I guess you know that one, it's not user-friendly at all. And the cryptography editors have invented something that is called the Certificate Life Manager that is meant to basically auto-renew web server certificate in your IT, but that works only in IT where everything is connected every time. You can ping servers from the CLM system, etc. So there is one bit that has been invented a few years back now, and it's quite blurry yet. That's why I'm calling for standardization. It's the key management system. The key management systems aims at filling those gaps by making your cryptographic ecosystem available for third parties, by bringing workflows and features to your users and partners, and by actually making life easier at scale. I will dive on it in a few slides, but first I'd like you to see the whole end-to-end chain of what's happening on the field right now. So what's in the background is what we'd like to avoid. We'd like to avoid people being able to reconfigure their car so they can drift and crash, actually, and have safety risks. So you have a nice little red car here in the middle. And the first bit I mentioned it is that you need to inject a root of trust on your car, and of course you'll do that in your factory. So you have factory software that does key injection at the bottom line. Then you have your network of resellers that would like to do some diagnostic. And today, each car brand is providing them with what is called here a diagnostic suitcase, which has multiple form factors, but now it's coming more and more to be a standard laptop that will plug in the car with a set of cables, of course. And it has its own backend. That's on the right of my slide. That's all the IT systems of my car manufacturer. And you need that car dealership to be known in your identity ecosystem, because you don't want anyone to sell on eBay diagnostic suitcase and then anyone to be able to reconfigure cars. And that's not something I'm inventing. If you go on eBay, you will find some diagnostic suitcase from all the major car manufacturers around. So once you have all that, you need, of course, some crypto systems on the car itself. I've put 2 examples here, but you can find many others. Managing certificate revocation list, managing renewal of certificates on the car itself, and of course, at each of the 100 ECUs you have on the car, you'll need to have some keys stored and some crypto capabilities to verify a signature, for example. I mentioned that my car was connected, so my car is connected to its off-board platform. I will not dive in what's in the platform, but you need to retain that you have a whole lot of data on each car that is an asset, much like a factory tool, to the automotive sector, and so you have vehicle master data that is being stored in the back office at the car manufacturer. And last but not least, I have my cryptography ecosystem that appears. It's a PKI that is, of course, based on hardware security modules. I guess you know that. And all that is being bundled up by my key management system that is in the middle of my tool. If I try and make a melting pot of all that, so you inject keys of your root CA that is hosted in your PKI in your factory. The cars go on the road. In the meantime, my reseller is being registered in my identity ecosystem. The mechanic, let's call him Paul, got his own suitcase. When he was in the car shop, he logged into the diagnostic suitcase and the backend, so he gets certificates on its own name. And when he tries to plug into the car generates a challenge, asks for a signature, the suitcase signs it with the certificate that is on my name, and actually I can log into the car and get access in a safe way. So I'm not managing any password locally. I'm not managing anything. The diagnostic suitcase is implementing the security, and in the end, no one that is not a trusted car dealership with a trusted diagnostic suitcase cannot do anything on my cars. So you can imagine exactly the same thing with a PLC. I mean, you have an engineering tool for your PLC that could rely on certificates that are actually emitted by an infrastructure that is on your own. So now let's dive a bit on what my client and myself actually are implementing to do so, the key management system. And then I will dive a bit on the customized certificate template we need to do so. So I mentioned it, my key management system is actually relying on the existing cryptography brick that exists on the field that you can buy, HSM, volts, PKI, that's the bottom of my slide. On the right of it, you have your existing infrastructure. You don't want to redevelop anything that exists. You have a security operations center that is made for traceability. You have identity and access management systems that are made to give and grant access. And you have your business application that have a whole lot of master data to be put in your keys or as metadata in your keys. So the heart of the key management system is to use keys, to generate them, and to, of course, manage their life cycle. Let's dive a bit. So usage, for example, encryption. You would like to secure a channel and secure a channel, and so you will encrypt only the symmetric key before transmitting it to a third party. You would like to sign some software because you have a supplier that would like to push an update. Well, you can perform signature at the KMS itself and retain the key where they are safe and give back the signed hash to your third party. And so you need to expose all those functionalities towards your suppliers and your users through interfaces. I've imagined some here. I mentioned it earlier. It's not standardized, so you will not find any document from the DoD or any security, let's say, think tank on the internet, but here you have administration portal, the key ceremony portal, the key management portal to manage your list of key and inventory, and of course APIs, because today you don't want your system to be man-made only. So I imagine also some roles you can have, your administrators, your auditors that would like to check that it's properly done. Some key owners. Key owners are in the heart of the business. They are people on the production line because they are the ones that enable the use case. Key operators, field operators. Field operators is my car mechanic, basically. And you have some tools discussing directly. So your diagnostic tool most likely is directly discussing with your KMS through APIs because you don't want any human interaction when your car mechanics wants a key. And of course, at the back of it, you need the management of the tool itself, workflow management, role management, segregation, etc. This is a heavy security tool, you've guessed it, because it's enabling a security feature that is unlocking my car. So you need strong management over it. One important bit is that I haven't told at all what I should put in the key as per metadata, or what I should put in the certificate as a common name or distinguished name. That's because there's no answer out there on the internet. There's no answer to multiple questions that I will raise. The first is, what granularity of access would I like to give? Would I like my car mechanic to be able to unlock any car on the field of my fleet? Would I like those authorizations to be only for a given model or given country? Would I like to be long time? Because, well, if it's long time, no problem of disconnection. But if it's short timed, I don't need to manage my key replacement or renewal because I can imagine that the key will fall short after 24 hours and the key, the management of key end of life is not a problem anymore. So you have 5 to 10 questions with multiple answers here that are not being answered by the industry, and that's why I'm doing that design in the car industry and That's why it's a bit painful to implement that cyber. It's because you need to answer each question every time for all the use cases I've shown before, and that ends up with hundreds of possible designs. So let's look at those designs from a high view, let's say. What I would like to emphasize here is that if we go for traditional access control, that is role-based access control, we might end up with a system that is not secured enough at scale. I would prefer to have more custom and more fine-grained tools on hand. Role-based access control, very short, I'm guessing you know a lot of it, is based on what you are. So you're an intern, you're in Miami, and you're in the test environment. I'm granting you accesses to resource. So that is something in production in most big companies today that allows more or less automatic access to business application once you enter the company. So you're a field operator, you enter a factory, I give you a set of access to application that are both HR, transversal application, but also business application to work on a daily basis. We can do better than that. We can do attribute-based access control. That is, based on your live attribute at the time you want to get access to something, I give you, or not, access to the resource. So I'm looking at where you are at that time you want to get access, what you are, what type of device you're using, and then I grant you access to a set of resource. That is called attribute-based access control, and you can do that by putting tags on users and resources that are matching, and I mean that works, and that's actually what Microsoft is doing on Office 365 and the Zero Trust world. Basically, if you are using an untrusted device or if you are an untrusted network, you will not be allowed to download that PowerPoint presentation, or you will not be allowed to modify it. And so my belief is that we can achieve that through certificates on the field if you have a strong enough infrastructure and strong enough design. And that's actually what the car industry is doing now for the most critical use cases. Not, let's say, on simple car, because the cost to benefit ratio is quite bad. If you look at a car that is 15K, a small car. But if you look at a big truck that is more 200 gallons, here you have something that works and you have really sensitive operation to perform. Now moving to something a bit more pragmatic, that is a flow, because cryptography is not magical, you know, there are some flows. It's what happens if the PKI I'm talking about for 20 minutes now is compromised. Well, the car industry has only one solution, that is vehicle recalls. Why that? Because I mentioned cryptography for unlocking the parts of the car, but cryptography is being used for many things. Since it's a basis of security, it's being used for software updates. Okay, it's being used for secure boot. It's being used for mutual authentication in the car. It's being used for traffic encryption inside the car. So if your PKI get compromised, you will have not many other solutions that to go to recall. The first step you will need to do is to understand the scope of doom. So with respect to the design choice I've mentioned earlier, how your infra is being built, you will know the precise cars that are being impacted, the precise models, the precise keys, and so you will size your doom down to what you need to do. Why will you need to recall? Well, it's because cars, unlike ICS systems, are not buried deep down in your infra under piles of firewalls. You know, regulators sometimes are asking you to have two technologies of firewalls, such as if one gets a vulnerability, the second one would not have one. Well, that's not true for cars. Cars are on the street, and I mentioned it earlier, if you have a vulnerability that is known, it will get exploited on the streets. And so the final bit is that, well, once you've recalled the cars, you need to replace the parts that are compromised in the cars, because they cannot be trusted anymore, and you will replace them in a trusted environment, that is the car the mechanic workshops. And hopefully you will be able to use the old parts and refurbish them to be trusted again. But that is not something you can do easily, and you will need to recall them back to your factory. I wanted to emphasize that flow because it's something that never happened yet. Jeep did a massive recall back in 2015, and I think it's quite a traumatism to the industry. They had to recall 1 million and something car because they had a cybersecurity breach. Maybe one important bit is that the safety tight part of the car are not connected yet, not updatable yet, so they won't suffer that bit. And also a final positive bit is that from, let's say, some months or years now, some car manufacturers, especially Tesla, are doing recall on air. So basically they're just saying your car cannot start until we have fixed something on it, and they do it over the air by patching. So let's now try and conclude on my pitch. I think there are still several gears to be shifted to move towards standardized and simpler solutions. That is, I've shown you what is not standard and what is being developed by myself, and I can add more questions on top of that. The first one is, will crypto hold the timeline? Because I mentioned it, we are looking at 30 years timeline. The algorithm I'm putting in car right now, they might not hold until 30 years from now, so we need and we are actually getting ready to replace the algorithm within the car. That's called crypto agility, but that is still a huge challenge. Second challenge is that the cars that are being designed today are not the cars that have been designed 10 years ago, and we are trying to make legacy systems and also legacy knowledge and legacy way of working coexist. Because the car engineer from 20 years ago that was designing embedded systems is not the car engineer from today that is designing IT, internet-based systems. So in a huge car industry, it's really difficult to make systems and people coexist in between time. Third bit is that I've worked on 3 projects on that matter to manage keys at scale for car industry because it's so important for them to secure their car. They all went for custom homemade development, mainly because the key ecosystem is so tied up with the car platforms and so integrated in the IT systems that there is no, let's say, simple solution, but also because it's not standardized. I mean, in the banking areas, key management systems are being used to encrypt databases and stuff like that, and software vendors are here. There are solutions that work to do so. It's not the case in the car and in the product industry. It's because it's not standardized. And that's, let's say, my final call and my take here, that human-to-product authentication, it's a basic of security. It's crucial. It would benefit from a more standardized approach. It would benefit from well-designed and well-engineered things to accelerate its go-to-market and drop the passwords we've seen in our PLCs today. So that is the main part of my talk. The car industry is a bit ahead of the ICS industry in that bit because they are already facing the challenges you are seeing in your factories. That is, factories are getting more and more connected. More and more people are trying to access the systems, and you need to connect them to clouds and to interfaces. And so I think we can draw easily parallels in between what I'm doing in the car industry, in the ICS industry, by bringing more security and more standardization to make security easier to adopt for our counterparts that are on the field. That's it for today. I'm Paul Chopineau, and I'm a network engineer at the beginning. That's why I'm working on connected objects like cars. And don't hesitate if you have questions.